Okay, to review the concept of center of gravity, we'll practice with an example. This one says, a flat dance floor has dimensions of L along the X is equal to 17 meters by length along the Y is equal to 19 meters and has a mass of capital M is equal to 1400 kilograms. Use the bottom left corner of the dance floor as the origin. Three dance couples, each of mass M is equal to 110 kilograms, start in the top left, top right, and bottom left corners. What is the initial Y coordinate of the center of gravity of the dance floor and three couples? B. If the couple in the bottom left corner moves 7.6 meters to the right, what is the new coordinate of the center of gravity? The first thing is let's draw the dance floor including the coordinate axis, okay? My X and Y coordinate axis. Now, let's add the dimensions that we were given. Next, we'll draw the couples. So we're told one is at the top left, one at the top right, one is at the bottom left. Don't forget that this is the origin, guys, okay? This is the origin right there. So how do we find the center of mass? Or, sorry, center of gravity. My mistake. Well, let's review the formula for it. It reads as follows. So the formula says that the center of gravity based on the Y coordinate is equal to the sum. Don't forget this Greek letter sigma means the sum. So we have one or more, well, usually more than one mass. And that's equal to the product. We're multiplying mass times Y location or Y coordinate. Okay, usually in meters. The I's over here, what they represent is whatever number of mass that is. So we have two masses, this little number would be 1 and 2 and so forth, okay? So this formula will get as big as the number of masses. For instance, I expanded it here at the bottom, right? If you had 3 masses, it would look like this without the dots. But the dots represent or signify that if you have more than 3 masses, well, this keeps going, right? Same setup, which is mass times Y location. Okay. For our problem, we have a system of 4 masses, 3 couples plus a dance floor. So it'll be slightly longer. Now let's write down what we know. That is the given. We know the mass of the dance floor. I'm going to call it mass 1 to keep consistency between my formula and the given. So capital M, I'll say is mass 1, and that is 1400 kilograms. Next, I know that the couples have the same masses, so I'm going to say mass 2 is equal to mass 3, which is equal to mass 4. Those are the couples, and I'm just going to call this mass M because it's the same. We were told that mass M is equal to 110 kilograms. We also know the dimensions of the dance floor. Along the X, we have 17 meters. And then along the Y, we have 19 meters. And we have to find the center of gravity in relation to the Y axis. So now what do? Well, let's write down the formula that would apply to this problem. I'm going to write it over here. So the center of gravity is just going to be the product of the masses times the Y location. And then we're going to divide by the sum of the masses. Okay, I'm going to clean it up a little bit because I know that mass 2, mass 3, and mass 4 are the same. And that means I don't need to write M2, M3, and so forth. I can just replace that with M. So let's clean it up a little bit. It'll look as follows. Okay, so now the question is, how do we find the Y coordinates? Okay, Well, we know that the only one that matters truly is the y coordinate for mass 1, which is the dance floor. Okay? Because the other ones, the mass is the same, so it doesn't matter which one you make y2, y3, y4, because the mass of the couples is the same. So how do we find the y coordinate? Well, let's think about the center of I keep saying center of mass, sorry, center of gravity of this dance floor. Well, most of our objects, regularly shaped objects, will have the center of gravity at the center. So somewhere, maybe here, no. So I think yeah, let's say it's there. Let's change that to green and move it a little bit. Yeah, let's say that's good. Okay. The symbol for center of gravity is something like this normally, and then they shade this part, but I'm not gonna do that. I'm just gonna leave it like that, like this. Okay. And then the couples, we can think of the couples as a point mass, so the center of gravity would be just in the middle of the couples. Sounds weird. Now let's find the coordinates of each point. Each of these 4 points. All the coordinates. Okay, let's find them. Let's start with the dance floor. Well, if it's at the center of it, then the coordinates, because the y, or along the y you have 17 meters, and along the y you have 19 meters, along the x you have 17 meters. So that means this coordinate, it's going to be 17 divided by 2 because it's at the center, and 19 divided by 2. So that means top left couple will have coordinates of 0, 19. Top right would have coordinates of 17, 19. And then bottom left couple, they're at the origin, so they'll have coordinates of 0, 0. I'm just using the fact that this is 17 meters and this is 19 meters. Okay? All right. So now let's label. We said the only one that really matters is this one, so this one will be y1. I'm going to make this one y2, y3, y4. Notice that y4 is 0 meters. So that means for our equation, we can cancel this one. A little bit easier. Now let's plug in our numbers. So this is how it would look like. Make sure you keep the units, okay? And notice how the units, after you do all the math, the kilograms will cancel kilograms. And then you end up with meters, and that's what you want. For sake of time, I already have it here. I plugged in all the numbers, just in the same way. And this is what we got, 10.10. So that means the center of gravity for y is equal to 10.10 meters. And that's it.